Hello students, I am Neeti Kapoor Badiye, Assistant Professor at Government Institute of Forensic Science, Nagpur. Today I bring you an interesting and learning episode in BSc Forensic Science on an important unit which is Fingerprint Part 5, General and Individual Characteristics of Fingerprints, in which we will discuss the various general characteristics that make up a fingerprint pattern, the types and subtypes of fingerprints according to Henry system of classification, followed by the individual characteristics. Let's start our episode with a look at what we are going to learn today. Module 1, Introduction. Module 2, Characteristics of Fingerprint. Module 3, Patterns of Fingerprint. Module 4, Rich Characteristics and Galton Rich Characteristics. Module 1, Introduction. Students, the work of police, judges and juries would be much easier if criminal left signed confession at the scene of their crime. That seldom happens, of course, but criminals often do leave identifying signature in the form of fingerprints. No two peoples, not even identical twins, have ever been shown to have exactly the same pattern of raised, curved lines on their fingertips. Each individual possesses a unique set of minute raised ridges on volar pads called friction-rich skin. These clear and apparent unique outline of the ridges are called fingerprints. A fingerprint is highly individualistic and forms the basic for personal identification in forensic examinations. Module 2, Characteristics of Fingerprint. Although it is true that each fingerprint is different from other, yet it is true that all fingerprints have common characteristics among themselves. The common characteristics that make up these patterns are known as pattern area, type line, delta and core. First one is pattern area. The area covering the portion of the fingerprint from which the fingerprint pattern can be determined is termed as pattern area. It is that part which constitute patterns, core, deltas and ridges with which we are concerned in classifying pattern area is present in all patterns, but in arch it is indefinable. Second one is type line. Type line are ridges that determine the pattern area of loops and whorl. Type line may be defined as the two innermost ridges which start parallel, diverge and surrounding the pattern area. Type line are not always the two continuous ridges. In fact, often they are found to be broken. The arches lack the presence of type lines. During the process of locating type lines, it is must to remember the distinction between a divergence and bifurcation. A bifurcation is a dividing or forking of a single ridge into two or more branches, while a divergence is the spreading apart of two ridges in different directions, which had been running parallelly or nearly parallel. Third one is delta or tri-radii. Delta, also known as tri-radii, is formed when a ridge bifurcates, when two arms of bifurcated ridges diverge, or when adjacent ridges running side by side diverge, causing an interspace within which the pattern lies. The triangular plot formed by the two divergent ridges and the first ridge in front of them within the base is called as delta or tri-radius. The delta may not be located at the bifurcation, which does not open towards the core but at the nearer end only. As per Federal Bureau of Investigation, The delta is that point on the ridge at or in front of and nearest the center of divergence of the type lines. The delta may be bifurcation, an abrupt ridge ending, a dot, a short ridge, a meeting of two ridges, or on a point on the first recurving ridge located nearest to the center and in front of the divergence of the type lines. While locating delta, the examiner has to be careful in fixing the type lines and determining the point of divergence of two type lines. In arch pattern, there is no delta. The loop pattern possesses one delta, while the whorl and composite patterns possess two or more delta. Core. Core is the central terminus of the pattern. It is approximate center about which the ridges form pattern. The point of core is important for correct ridge counting and for correct interpretation of loops and whorl. In arch patterns, the core is absent, but loops and whorl have one core. In double loop patterns, there are two cores. The core of the loop may consist either of an even or uneven number of ridges, terms rod, not joined together, or it may consist of two ridges formed together at their summit, where the core consists of an uneven number of rods. The top of the center rod is the point of core. If the core is staple, the shoulder of the staple that is farthest from the delta is taken as a point of core. The nearer shoulder counting as a separate ridge, where the core consists of an even number of rods. The number of central one are considered as joined at their summit by an imaginary neck, and of these two, the shoulder farthest from the delta is the point of the core. In circular or elliptical whorl, the center of the first ring is the point of the core. Where the whorl is spiral in form, the point from which the spiral begins to revolve is the point of the core. Point of the core is synonymous with inner terminus. Student, this may sound a little bit tricky. Well, it is. Only practice will make you perfect. Loop patterns may consist of even or uneven number of ridges not joined together, which are called as rods. The core, which is placed upon or within the innermost sufficient recur. If there is no rod rising as the shoulder of the loop, the core placed on the top of the shoulder, which is farthest from delta. Let's begin module 3, patterns of fingerprint. Fingerprint patterns are determined by the configuration of the ridges appearing on the distal phalange of the fingers. It is the shape and direction of the ridges, along with consideration of type line, delta and core, that constitute a fingerprint pattern. To a layman, the classification of fingerprint may appear to be a complex problem, and he may think that it is most difficult, if not impossible, to classify fingerprint of millions of individuals. But this is strange but true, that everyone born with a fingerprints are having different design, which can be classified into types and subtypes. Different researchers have come up with different classification, but in India and many countries of the world, Henry system of classification is most accepted for the purpose of examination. In Henry's system of classification, patterns are divided into 4 types and 10 subtypes as follows. Arch. In arches, the ridge is entered on one side of the fingerprint pattern and exit on the opposite side without recurving, but there is slide hump-like structure at the center of the pattern. There is no core, no delta in the arches. Arches constitute about 5% of the fingerprint pattern. There are 2 subgroups that further defines the arch pattern. First one is plain arch. Plain arch is the simplest of all the fingerprint patterns and is easily distinguished. In this, the ridges start on one side of the impression, then the ridges cascade upward slightly, almost resembling a wave out on the ocean, and then to the other side. This pattern has a consistency of flow to it. There may be numerous ridge formations such as ridge ending, bifurcation, dots and island evolves in this type of pattern, but they are all tends to follow the general ridge contour. That is, they may enter on one side and make a rise or a wave in the center and flow or tends to flow out on the other side. Next one is tented arch. The pattern in which most of the ridges enter from one side of the impression and flows towards the other side like a plain arch, but in which the ridges at the center have an upward thrust in the shape of tent arranging themselves on both sides of spine or axis towards which the adjoining ridges converge. There are three types of tented arch. In the first type of tented arch, ridges make a definite angle of 90 degree or less. In second type of tented arch, one ridge at least at the center form a upthrust. An upthrust is a ending ridge of any length rising at the sufficient degree from the horizontal plane, that is 45 or more. In third type of tented arch, there are two types of basic characteristics of the loop, but it lacks the third characteristics. First characteristic is sufficient recurve, second is delta formation, and third a ridge count across the looping ridge. Next type of pattern is loop. In loop, the ridges enter from one side of the impression, moves towards the center, recurve and return towards the same direction from where it is started. A loop has one core and one delta. The pattern is identified as a loop provided it possesses the following compulsory characteristics: a sufficient recurve and a delta, a ridge count across a looping ridge, at least one. This pattern is the most common and constitute about 60 to 65% of all prints. Loops are subdivided into two main types, radial loops and ulnar loops, according to their positioning and the flow of ridges. The term radial and ulnar are derived from the radius and ulnar bones of the forearm. The classification of loops is based on the direction the loops flow on the hand, not on the fingerprint slip or card. The first one is radial loop. When in a loop, the ridge flow from and terminated in the direction of radius bone of the forearm, that is, when the loop opens towards the thumb or radial bone, it is termed as radial loop. In case of the right hand fingers, the ridges slide towards left, and in the left hand fingers, the slant is towards right side. Next one is ulnar loop. When in a loop, the ridges flow from and terminate in the direction of ulnar bone of the forearm, that is, when the loop opens towards little finger or ulnar bone, it is termed as ulnar loop. In case of the right hand fingers, the ridges slant towards right side, and in left hand finger, the slant is towards left side. Third pattern is whorl. The pattern in which the ridges recurve in circular manner and at least one of the ridge make a complete circuit around the point of the core, as classified as whorl. These patterns must have at least two deltas and a recurving ridge in front of each delta. The line joining two delta must touch or cross at least one of the recurving ridges in the pattern area. The whorl may be circular, spiral and oval in nature or any variant of the circle. The whorl pattern are subclassified into two types. First one is plane or spiral whorl. In spiral whorl, one or more ridge revolve spirally either clockwise or anti-clockwise around core to form complete circuit. It consists of two deltas and one core. Second one is concentric whorl. In concentric whorl, core is at the center and one or more ridge revolves around the core at the center in the form of concentric circles. It comprises of one core or two deltas. Fourth one is composite. When two or more patterns combines to form one pattern, that pattern is called as composite patterns. They may be subdivided into four types. First one is central pocket loop, lateral pocket loop, twinned loop and accidental. First one is central pocket loop. In this pattern, majority of the ridges have the appearance of loop, but one or more ridges form pocket-like structure at the center. Like whorl, at least one ridge make a complete circuit about the point of core and there are two deltas, but unlike whorl, the imaginary lines drawn between two deltas does not cross or touches the recurving ridges in the center of the pattern. Student, these patterns roughly look like a balloon with a string or a lollipop. Interesting, isn't it? Second one is lateral pocket loop. It is the pattern in which there are two separate and distinct overlapping loops with separate shoulder and two deltas. At least one ridge in each loop must be independent of the other loop. There are two deltas and two cores. In this pattern, usually the deltas are located opposite to the direction of opening of the loops, both of which opens in the same direction. Third one is twin loop. Twin loop, the pattern in which two separate and distinct loops are present with separate shoulders, two cores and two deltas, and the core forming lines open towards either side of the deltas is classified as twinned loop. Fourth one is accidental loops. The pattern which is too irregular to be classified in any of the previous pattern is termed as accidental pattern. This pattern may consist of combination of two or more than two different types of patterns and may contain at least two deltas but as many as 4. Module 4, Ridge Characteristics or Galton Ridge Details. Identity of fingerprint is established by comparing suspects or question sample with control samples. Matching of the fingerprint based upon the study of ridge characteristics of fingerprint, that is ridge count, ridge tracing, ridge density and minutiae. First one is ridge count. Ridge count is the number of ridges crossing or touching or intervening an imaginary line drawn between core and delta. Neither core nor delta included in the counting procedure. For the determination of accurate ridge counting, the examiner must locate exact core and delta. Otherwise, error in locating these fixed points may result in wrong ridge count. The ridges are counted between core and delta, but the point of core and delta are not included in the count. If the imaginary line passes through the enclosure, a ridge count of 2 is made at that time. While passing through the enclosure, the line may pass through the center or through bifurcating ends. If the imaginary lines touches the point of bifurcation, a ridge count of the 2 is made at that point. If the line touches a ridge dot, a count of 1 ridge is made at that point. A loop pattern must have a ridge count at least 1, and in different cases it may be as high as 25 to 30 ridges. In whorls, there are 2 deltas present. It is possible to have a ridge count on both the sides, that is right and left side. Next important point is ridge tracing. Ridge tracing is an identification feature in whorl pattern. As the whorl are subclassified by ridge tracing, the initial examination of whorl pertain to a determination of the pattern itself. The fingerprint to be identified as a whorl must possess 2 deltas. Once the deltas are identified and located, the procedure of the ridge tracing involves the tracing of the ridge started from the lower side of the left delta until the point nearest or opposite the extreme right delta is reached. the number of ridges intervening between the tracing ridges and the right delta is counted. First one is inner tracing. If the ridge traced beginning from the left delta passes inside or above the right delta and 3 or more ridges intervene between the tracing ridge and delta, the tracing is said to be an inner and is designated as I type. Next one is outer tracing. If the ridge traced beginning with the left delta passes outside or below the right delta and 3 or more ridges intervene between the tracing ridge and delta, the tracing is said to be outer and is designated as O type. Third one is meeting tracing. If the ridge traced beginning with the left delta exactly meets the right delta or passes within 2 ridges below or above the right delta, the whorl is said to be meeting type and is designated as M type. While tracing the ridge from the left delta, it should be carefully noted that if a ridge ends along a tracing line, tracing continuous on the immediate lower ridge, and if the trace ridge bifurcate, tracing continuous along the lower branch of the bifurcation. Third important point is ridge density. Fingerprint ridge density is the number of finger ridges that touches the diagonal line drawn between a square of 25 mm square, which is placed on the core of the fingerprint image or at some other fixed predetermined point established by published research studies. It has been found to be useful as a sex determination aid in forensic practice as a ridge density values are significantly higher in females than males. This information facilitates the investigating officer to narrow down the investigating process in a particular case and direct the criminal investigation towards suspects belonging to the most likely sex. If the sex of the suspect can be defined, their work scope could be narrowed down to almost half. To facilitate and shorten process of investigation, finger ridge density become relevantly useful. Last one is minutiae. The friction ridges have certain basic features which are present in sufficient number in every fingerprint. These characteristics features could be made more elaborate on magnification of the fingerprint. A single clear fingerprint may process as many as 100 or more characteristics features in the form of fine minute details of the ridges in the complete print area of the finger impression. Following are the main characteristics of ridge formations commonly found in a fingerprint impressions. Ridge ending. When a normally flowing ridge ends abruptly, that characteristics is known as ridge ending. This is a ridge usually placed between two other or more or less parallel ridges. It ends abruptly and does not reappear. Next one is bifurcation. A ridge which leaves the left side of the pattern and divided for a certain length into two parallel lines is known as bifurcation. Third one is trifurcation. A ridge which leaves the left side of the pattern and divided for a certain length into three parallel lines is known as trifurcation. Next one is convergence. This is similar to divergence. Bifurcation, but it is reverse or a mirror image. It is formed by two parallel ridges which leaves the left side of the pattern and fuse or converge to form a single ridge. Next one is deviated break. An interruption formed by two ridges which instead of stopping just before they meet suddenly deviate, forming two ridges ending with a furrow between them. Interjection or bridge. The junction of the two parallel ridges by a short diagonal ridge which meet the ridge at very acute angle. Next one is fragment or short ridge. a ridge which finish abruptly and of variable length. The fragment may be small or large in size. Interruption or natural break. This is a natural break or interruption in a ridge. It is in its formation similar to two ridge endings facing each other. Next one is enclosure. This is the shape of ellipse. It is formed when a ridge bifurcates into two ridges and converges again to a single ridge almost immediately, leaving a blank space within the ridge. Enclosure may be small or large. The extra large enclosure may be referred to as a lake, point or dot, a very small formation of ridge which is only as long as it is wide, which is usually found in the middle of interruption or delta or between two ridges. Intersection. It is found when one ridge intersects or cut another ridge. Next one is changeover. It is formed when two parallel ridges change their places. One ridge is interrupted while the other takes its place by passing through the break. Next one is return. A simple ridge which suddenly turns upon itself and returns the way it has come, forming a rounded loop without a core. Next one is hook. It is formed when a ridge bifurcates into two and one bifurcated ridge only continues further while the other does not and appear to be attached to the ridge as an appendage ridge at an angle. A hook may be of following kind: an upward hook, downward hook, rightward hook and leftward hook. Students, these were the common characteristics, patterns and their subtypes and rich characteristics which are used for identification, individualization, characterization, comparison and matching purpose in fingerprint science. I hope you had a fun time learning them, so till the next time, keep learning and keep practicing. Thank you.